Hi guys, Mr. Hedrick back here to show you how to do another type of factoring problem. In this case, we're going to look at a trinomial, which means three terms, and how to break that down as well. So again, factoring, breaking problems down. Sort of the same step that we did with our binomial problem, where we first set our expression equal to 0. This is to find the root 0 solutions that will again match the real solutions to a graph. At the end of the problem, we could graph this, we could compare that. So I'll leave you to do that. Again, in this case, what we want to do to break this down is to set up a box. And first term will go in the first box, last term in last box. We'll ask ourselves what times what equal these monomials. And in this case, as with the last one, x squared times x squared is x to the 4th. Now there's multiple things that could multiply together to give you that negative 63. A couple of examples would be 1 times negative 63, negative 1 times positive 63, 7 times negative 9, negative 7 times positive 9. List all the options out that you have and then work through which of these options will help you to add up numbers that equal your middle term, negative 2. Now obviously in this case it should be pretty apparent anyway that the larger numbers like positive negative 63 are not going to help you. Students sometimes get confused with this where they struggle with the signs. This is where always want to double check yourself. In this case, if you test with negative 7 and positive 9, for example, you will see that positive 9x squared and negative 7x squared don't add up to equal the middle number. So we need to flip the signs, which is possible. Okay. And all of a sudden, 7x squared minus 9x squared is negative 2x squared. The whole box does match what we started with in green, and that indicates that we have found the factorization or the breakdown that we are looking for. Here are the factors of the original expression, x squared minus 9, x squared plus 7. Okay. Again, these are the factors. This is the factorization initially. Now, we always need to check though, is there more that we can break down? Is there more that we can factor? And in this case, as with our other example, yes. Now this doesn't always happen, but definitely consider perfect squares as you're looking at these problems, and 9 is a perfect square, so we would want to yet again make a box. This is a binomial, so our corner boxes should cancel. We have x times x is x squared. What's the square root of 9? Plus and minus, okay? Positive and negative, 3. And to double check ourselves again, we would do 3 times x and negative 3 times x and see, yes, they do cancel as they should to equal this original factor. And once we break down that parentheses, we are in a position at that point, excuse me, okay, x plus 3, x minus 3, x squared plus 7 that we had from earlier. We are now in a position to set everything equal to 0 separately, solve for our roots and zeros. Now in some cases these all might be real, in some cases you might have non-real solutions, so we have to watch out for that. Okay, opposite operations, move numbers from one side to the other. That's a real solution that does not have I, that will show up on the graph of this original function as an x-intercept. Likewise, with this root 0 or solution, okay, negative 3 and positive 3. And for this last case, okay, don't forget that when you get to this point, you are not quite finished. You do have x squared there, you need to square root both sides to eliminate that exponent of 2. And don't forget your plus and minus symbol, as well as if you have a negative under a square root, you should end up with I. Imaginary, complex, non-real solutions. The square root of 7, we can't do anything with that. Now remember, if you end up with a number that is not a perfect square, you still have to try to think about, are you able to break that down? Something like the square root of 8, you could break that down into a square root of 4 and a square root of 2. Here, that again tells us that we have multiple non-real solutions. I's always come in pairs. So that's 2 non-real solutions, 2 real solutions. There's a total of 4 here. Again, that matches your degree, and this completes our factoring problem. So again, take a look at page 1. You should be able to do all of those now, and I'll see you back.